All right, good morning, ladies and gentlemen. Happy Tuesday. So the purpose of this video, I'm going to show two things that we can add to our interactive notebook. One is a foldable, one is just working through some word problems. So both of these will be helpful for solving what we're going to be doing in our next unit. Specifically, this foldable right here that I'll be showing, I'll throw up online, and this video is to how to cut it out, how to glue it in, and then what to add. This will be helpful for our next unit because we're going to be talking all about something called linear relations. And then for our other one, it's what I call the guess method. It's for solving word problems. It'll be helpful for going over some of our finance problems if it's a word problem, or just in general if you have a word problem, how you can break it down and make things easier. And you can apply this to basically any type of math problem. I use it for my grade 11s. I use it in university. I found it really helpful basically just to dissect questions and figure out what I want to do. So we're going to start with this. So first up, when you get it, there might be some issues with printing. If you just try and print this, it'll print it upside down. So one of the ways around this is if you have the paper, you can print it on 2 sheets and then print it together, and then you just flip one side upside down on your printer and it'll make it so it'll fold nicely. Another option would be to print it as 2 sheets of paper and then just glue them back to back so that it's facing the right way. Either one should work. So what we're going to do first, this side is the important one with all the information, so I'm going to cut out around here first. So as I'm cutting, I'm just going to talk a little bit about each part and why it's helpful for us. So this is our coordinate grid. So some of you, this will be stuff that we've probably talked about at some point, but it's helpful for us in the same way that it'll be helpful for just to have this sort of ease of working through these problems without any sort of delay or any sort of confusion. So when I say the coordinates 2, 3, we know exactly where we can find that. When I talk about something like the origin, when I talk about the slope, so it gives nice definitions for each of these and breaks them apart. So first step is you want to cut all the way around so it can fit nicely in your notebook. So it'll look something like this. Now this is the side that's going to go into your notebook, so this is going to be the outside. You'll see that there's some dotted lines. What I'd recommend doing, just because we're about to fold this, is that the first thing we should do is cut just the top ones here. So you should end up with a small strip and then 2 larger strips. The reason being is I want to fold this piece and this piece, but I want to leave the top part alone because that's going to be where my label is. And I want to fold it in like so. So I'm going to do that right away. You can cut them first, but I find it's better if I wait. So I'm going to fold both sides and then I'm going to cut it. So pre-cut, it'll look something like this. So when it glues in, this will be the side that you see. And then what I like to do is I like to go in and I'll cut the other 2 dotted lines, because what we're going to have is 4 little windows that'll say quadrant 1, quadrant 2, quadrant 3, and quadrant 4 on the outside. So when you're done cutting, it'll look something like this, where each window opens up. And how you're going to glue it into your notebook is if this is your notebook, it's going to go in on your next available page. So for example, I'm going to go past my LCM, and one of the things, depending on your notebook, it might be a little bit too big. So what you can do, not a problem, you just trim the edges of that sheet of paper. So then you should end up with a slightly smaller XY coordinate grid, and then you can glue that into your page. And then we're going to open it up. Before we do that, I just want to kind of point out one thing. So one thing I just noticed, I've actually got my quadrants in the wrong section, and that's because I printed it incorrectly. I'll show you how you can go in and print the PDF correctly, but basically when it goes into your notebook, it should look something like this. And I'll show how the quadrants are supposed to go, just so we have an idea of if you did it right and I'll show how to correct that. So I'm going to pop over into the screen capture and I'll show you a couple different things. Alright, so this is my Word document. You'll have a PDF version of your own. So one of the things, you want this section here to be quadrant 1. I'll show it on a different picture how it's supposed to look, but basically you want it to be quadrant 1, quadrant 2, quadrant 3, quadrant 4. So if you print it as 2 sheets and then backwards and flip one of them, what will end up happening is that these 2 will be flipped and then these 2 will be flipped. So the way to get around that is if you go to print, if I try to print, you should get an option in Microsoft and it'll say print one-sided and then print on both sides if you have a fancy printer, and then you want to flip pages on the short end. So that'll flip the left and right, so it should come up being the right way. So hopefully that helps. Now I'm going to go over and show what we can add to this. Alrighty, so here's what we're going to add to our foldable. Now one thing though, just so you're aware, when you're setting this up, the printing might be a little bit off. So I've shown maybe one way that can fix it, but keep in mind what we're looking for is this. So quadrant 1 is always going to be the top right, and then we're going to go around counterclockwise. So Q2 is our top left, quadrant 3 is our bottom left, and quadrant 4 is our bottom right. So how I currently have it set up here on the screen, notice how quadrant 1 and quadrant 4, quadrant 2, quadrant 3 all line up. It should look like that, but you might have it as, or however you print it, it might be different. So just make sure, the most common thing I've seen with myself is that these 2 end up flipped with these 2. So just make sure that you go in and change that if that's the case. Just cross out the numbers and make sure that you have kind of on the inside what you're looking for is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. You can put those there, or you can make sure that the pages line up. Either way works. And we're going to go through and we're going to start with quadrant 1. So this is this section here, this sort of upper right. The way we can think about it is that it's above the x-axis and it's to the right of the y-axis. So anything in this realm, for both our x and our y values, are going to be positive. So a good example would be the point 1, 2. So if I do 1, 2, I'm going to go over. So keep in mind our first value is going to be our x and our second value is going to be the y. So I'm going to go over 1 to the left. So I'll make a little hop, and then I'm going to go up 1, 2 spaces to right here, make a dot, and I'm going to call this point 1, 2. So that's how we put points onto a quadrant, or onto a XY coordinate grid. One of the things I want to talk about, because it's going to be important for when we actually start dealing with linear equations, is something called slope. So one of the things you might hear is rise, or I'll do it as an equation, rise over run. But this is basically how much the line that we're dealing with is sloped up or down. And how we deal with it is lines that go up and to the right. So I'm going to draw what I mean, and I'll write up and right. We say that these have a positive slope. So for now, we're just dealing with if they're positive or negative. And basically any line, so if the line is up here, looks like that, or down here and looks like this, so long as it's going up and to the right, or has this sort of look to it, it's going to be a positive slope. Oppositely, if lines go down and right, or instead they look like this, we're always going left to right, so I'm always going to say up and right or down and right. If I say down and left, it's going to start getting confusing, so I'm going to leave that out. What I just mean is if our lines look like this or like this, they're going to have a negative slope. And the third type that I'm going to talk about is if they have a horizontal line, it has a slope of 0. So the way we can think of slope is if we have a person walking, are they walking downhill, are they walking uphill, or are they walking along a flat surface? Now you might be asking, well, what about a vertical line? We've done horizontal. I'll get to that later. For now, thinking of it with our walking analogy, it's a little bit hard to walk on. So I'll leave it there, and we'll talk about that part later. So I'll move over to quadrant 2. So over here, we are still above the x-axis. So if we look at going above the x-axis, we actually see that we're still in the same area of where the y numbers are. So in fact, it has the same values for y, but now I am dealing with negative x values. So an example might be something like -2, 1. So I've flipped the numbers and I made one of them negative. So now I'm going to go over 1, 2 to the left, and I'm going to start from my center point or my origin, which I'll talk about in a moment, and then I'm going to go up 1. So my point -2, 1 is right here. By the way, when I draw these, I show going over 1, 2, and then 1, 2, and then up 1. It is just as valid for me to go up 1 and then over 2. It'll get me to the same point. I just like to read these as x value first and then y, so I go over 1, 2, and then I go up 1. I try to find a way and stick with it that works for me, so it's up to you. Origin, this is the center point where the x-axis and y-axis meet. So it's right here, and we give this the point 0, 0. So it's right in the middle, it's right at our starting point. We're going to be using the origin a lot, so make sure you have the definition of origin well put into your brain, because I will just be like, we're going to start at the origin. Or a question might say, starting at the origin, do this. So it's always a good idea to have what they're talking about in mind. Moving on, quadrant 3. Now I can see that I'm directly across the origin from my first quadrant. And in this case, I am below the x-axis and to the left of the y-axis. I actually have negative for both my x and y values. So for here, I'll do -2, -4. So again, I'm going to go left 2 and then down 1, 2, 3, 4. Or I can go down 1, 2, 3, 4 and over 1, 2. I should end up at the same point. So I'll put -2, -4. So we're going to talk about the x-coordinate. There's a few things for it. This is the first digit in an ordered pair. And that's always the case. So when we write out these values, so when I have an ordered pair, it's always going to start with x and then be my y. And if you keep going in math, we can add another one, we can add a z-axis, but we're always going to start with the x first. And this is, so it controls the left and right position. So you can think of it as moving our point either left or right, or side to side, or horizontally. However you want to think about it, it moves things sideways. Moving on to our last part, quadrant 4, coordinates have in this case, I'm in line with my quadrant 1 for my x. So it has a positive x value and then it has a negative y value. So an example would be, I could do +1/2, -3. So in this case, I'm going to do the y value first. So I'm going to go down 1, 2, 3, and then I'm going to go over a half. So I'm going to go about, try to estimate halfway, and I'm going to put a dot so I can have the point 1/2, comma, minus 3. And by the way, it's totally fine to have fractions or decimals in as a coordinate. That's not a problem. Last thing I want to talk about is the coordinate. This is our second, or the y coordinate. This is our second digit in our ordered pair, and it controls up and down position. So if you notice, the second value in all of these has controlled how far up or down I moved, and the x, or the first digit, controlled how far left or right. So make sure you have that in your mind for how we set this up. That's it for this one. Glue this into your book and then go to a new page, and I'm going to show you a way for solving word problems. So put this into your interactive notebook, and this is a method that I have found works really, really well for me. We're going to solve a word problem with it, and you're going to see how we use it. I like to call this Mr. Sproule's guess method. Now, guess, as you can imagine, is an acronym. I'm not actually telling you to guess when it comes to word problems. So guess stands for givens, unknowns, or unknown, equation, separate, and then finally solve. So this is our order in which we do word problems in. So we're going to start here, and we're going to work our way down. In some cases, you might only need to use a couple of these, but slowing yourself down and solving word problems this way will make things way easier. So the first step for givens is list everything that the problem gives you that is relevant. So relevant for solving our problem. So let's look at an example and break it apart. So Mel is paid a monthly salary of $3,385.20 for a 35-hour work week. What is Mel's pay per hour? So for example, the question tells me a person's name is Mel, but I don't really care for solving this problem. It could be named Gary, it could be named Roger or Becca. It really doesn't matter. So numbers are a good place to start. So I see monthly salary of $3,385.20. So my givens, I have a monthly salary of $3,385.20. Second number I see is a 35-hour work week. And really that's all it tells me. The next part, unknown, is what is the question asking? Notice how before I even care what the question is asking me, I am restating what the question is telling me. That way I have reinforced in my mind what is important. My unknown is Mel's hourly pay. Now I could give it an equation, or I could give it a variable, so I can call it, say, P. In this case, it's going to be less helpful, but in other equations it might be. Next up is equation. So there's two options here. you are going to either list or make an equation that uses the above information, as much of it as you can. In some questions, they give you a little bit too much information. In some cases, they give you things that'll be important for part B or part C. But in any case, try to look for an equation or make one that deals with the numbers here. So for example, we've learned about simple interest. Simple interest deals with time, it deals with money, but it's not very relevant here because we're calculating something different. So it's not going to help me solve for P. So my equations, in this case, there's a little bit of a wrench. It gives me monthly salary and I want to go to weeks. So I'm thinking to myself, I need to go months to weeks. And an issue with this is that every month is a little bit different and there isn't a simple amount of weeks that I can deal with. So unfortunately, I can't just use something like 4 weeks per month. There's roughly 4 weeks, but 4 weeks is only 28 days. So I actually need to think of months, and I need to think of a common thing that I connect it to. So in this case, I see that years I can make a connection to, and then I can go to weeks. So in this case, I'm going to have 3 equations, because then I can go from weeks to pay. So my first equation, I'll call it number 1, is I'm going to do months to years. So I'll calculate yearly salary is equal to monthly salary times 12. Notice how I'm not plugging in any of my givens yet. Next up, I need to go from yearly to weekly. So my weekly salary equals my yearly salary. Oops. And in this case, there's 52 weeks in a year, so I'm going to divide by 52 weeks. And then lastly, my third equation is going to be my pay, so I'll call it P is equal to my weekly salary divided by my work week, or hours. So notice one of the important things here, each equation connects to the other one. So I've calculated yearly salary to solve for this one, and I've calculated weekly salary to solve for this one. So I need to go in order to solve the next one. Separate, one is dependent, sometimes it's already done for us. We want to rearrange our equation so we have unknown equals, and I'll just put in brackets, we want our unknown on one side of our equal sign, and we want our givens with a bunch of math on the other side. The reason being, I don't want to try and solve for an unknown when it's buried into an equation. I want to make sure it's what I'm looking for equals a bunch of other stuff. Because a bunch of other stuff, if it's just numbers, I can solve that without an issue. So for example, say you were dealing with I equals PRT. This is our simple interest formula that I was talking about in a previous video. Say we had to solve for R. We would rearrange this so we would end up with R is equal to I divided by P times T. And to get there, there's a number of ways, but most commonly I see that there's a P multiplying, so I'm going to do the opposite and divide by P, and I'm going to divide this side by T. So I would do the same thing on the other side of the equals. So now these cancel out, and I end up with this on the opposite side and this on this side, and I just rearrange it. In this case, because all I need to do is plug in numbers and then solve, and everything that I'm trying to solve for is on the left-hand side and it's by itself, I actually don't need to do anything for separate in this equation. And then finally, our last one, if we're dealing with solve, this is plug in numbers and solve it. So for here, I'm going to start at 1. So I'm going to take $3,385.20, and I'm going to multiply it by 12, and that's going to give me $40,622.40. So this is my yearly salary. So then I'm going to plug it into this equation. So I'll put weekly equals 40,622.40 divided by 52. And that's going to give me $781.20. So that's my weekly. So then finally I end up with P is equal to, and now I have two things to bring in. So my weekly salary is $781.20. And this is where I'm going to take my other given, because it's 35 hours in a work week. So I'm going to divide by 35. So I get 22.32. So then finally, because this is a word problem, I want to answer in a sentence. The reason being, a lot of these problems are questions that you might get asked. Maybe someone will be like, hey, what does Mel make? And you're not just going to shout numbers at them. You're going to try and give an actual rational response. It also helps for catching mistakes and making sure that you have the units right. So in this case, I'm going to say Mel makes 22.32. Well, 22.32 what? Does she make 22.32 melons or grapes or dollars? Oh, it's probably dollars, because we were talking about money. And another check, if I'm talking about dollars, I'm ending at 2 decimal places, because that's my cents. And finally, the question was asking hourly, so I'm going to put per hour. Done. So notice in this one, I had to make equations that work. In other ones, like simple interest, the equations will be given and you need to manipulate and work with them. But in a lot of cases, you may have to reason and make your own. So I find this way is really, really good for showing and breaking things down into steps. For example, I could have easily rearranged this 3 equation into 1. However, it would have looked something along the lines of this. Now, it says the same thing, but it's in a lot more steps. I honestly find that if I can break things down into 3 steps of just dividing or multiplying 2 numbers, it's way, way, way easier. I don't make mistakes on my calculator. I don't make mistakes writing things out. I find that slowing myself down just that little bit saves me so much grief in the long run. So when Mr. Sproule, when you have a question and it's a word problem and you're having a hard time, and I might ask, well, have you guessed? I'm not asking you to guess. I'm asking you to do this. Slow yourself down and write down what the question is giving you, what the question is asking, and to go from there. Because in a lot of cases, it's actually kind of hard to see what the question is asking unless you take the time to kind of break it apart into very simple steps. In any case, that's all I have for you today. We're going to start on our new lesson probably. I realize we have a collab section tomorrow, so I'm not going to be posting a video in the morning. I might post a quick one in the afternoon, but then we're going to start the ball rolling with linear relationships and linear equations in the next couple days, and also when I see you again next Monday. That's all I have for you today. Take care, stay safe, have a good one. Bye.